You know yourself, if you had to push something or kick something, that the smaller object would be much, much easier to move faster. And so the answer to that is the one with the smaller mass. So down here it says, the lower the mass, the greater the acceleration for a specific force. This is why Grand Prix cars get actually faster on the final laps as they use up their fuel. Less fuel means less mass, and less mass means a greater acceleration. Now this is all given by a law called Newton's second law, and it's remembered as F equals ma. And Newton's second law, I'm going to write N2 law here, is a law of unbalanced forces. So you've already met in our forces podcast that Newton's first law is a law of balanced forces, and if those forces aren't balanced anymore, then they are unbalanced, and Newton's second law applies. So we express Newton's law as the relationship between force, mass and acceleration, and it's given by force equals mass multiplied by acceleration. But it's very important that you realise that that force is the resultant force. So if you have a mass which has two forces acting on it, and one of them is 10 newtons and the other is 2 newtons, then the overall resultant force is going to be 8 newtons. And the object will move in that direction with a resultant force of 8 newtons. How much it accelerates by will depend on the mass of the object and that resultant force. So we connect those three things with the equation force equals mass multiplied by acceleration, and we often call that F equals ma. Force is measured in newtons. Mass has to be in kilograms, be careful about that. Sometimes you'll be given masses in grams. And acceleration is in meters per second squared. This is just another way of writing meters per second squared. So we're going to use this force to do a few calculations. And the first calculation, what force will make a mass of 4 kilograms, so m equals 4, have an acceleration of 5 meters per second squared, so a is equal to 5. So if we use F equals ma, which is 4 times 5, that gives us 20 newtons. And that's the answer to that first question. Again, I should have said this at the beginning of the questions, but feel free to stop the podcast and then click off the pause button and play it so that once you've done your answer. Question 2, a force of 50 newtons acts on a 2 kilogram mass. What will be the acceleration of the mass? So again, we're using F equals ma, and F is equal to 50, mass is equal to 2 times a. So to find an answer to a, we must divide 50 by 2. And the answer is 25 meters per second squared. The third question, a force of 2,000 newtons accelerates a car at 2.5 meters per second squared. What is the mass of the car? Now in this case we haven't had to do a calculation to actually calculate the resultant force first, but very often in an exam question they'll give you 5 marks, and that's the first thing you have to do, is calculate the size of the resultant force, or possibly it's to find the size of a frictional force and you're given the resultant force in the first place. So F equals ma, and F is 2,000, and that's equal to m, which we don't know, and it's multiplied by 2.5. So m is going to be equal to 2,000 divided by 2.5. And we'll just check that in the calculator. Divided by 2.5 is equal to 800 kilograms. So m equals 800 kilograms is the answer. Alright, this is a force question. It asks you to label the forces acting on a moving bike. And you can see the person, the driver's pointed forwards in this direction. So we're going to label them. So A is thrust, B is reaction force, so that acts between the wheels and the ground. E is gravity, or we would call that weight. and its effect of the force of gravity acting on it. And C and D are air resistance and friction between the wheels and the ground. Fill in the table. When does the bike accelerate? So we know the bike accelerates whenever this forward force A is greater than anything moving backwards. And so therefore A has to be greater than C plus D, and the bike is accelerating. B and D should be balanced. There's no movement up or down of the bike, so they don't even come into the questions here. The next question is, when is a bike moving at a steady speed? So we know there's steady speed, that's Newton's first law, law of balance forces. So that means anything forward must equal anything back. So we're looking for A equals C plus D, and there it is there. Now, the bike could still be moving forward but slowing down. And in that case, it's already moving forward. The force A must be smaller than forces C and D. So if the rider has put on his brakes, then that increases the backward forces significantly. And in that case, C plus D must be greater than A. Even though it's still moving forward, C and D are actually slowing it down. So A is less than C and D is the answer to that question. Right, this is a question about a swimmer, and her name is Judy. She has a mass of 60 kilograms. She is swimming in a 25-metre pool with an average speed of 0.8 metres per second. Find the time it takes her to complete one length. So, we know that speed is distance over time. I'm going to call it SP, so we're not mixed up with displacement. And we're looking for time. So time is distance over speed, if you rearrange it. And the distance is 25, and the speed is 0.8. So 25 divided by 0.8 gives you an answer of 31.25 seconds. And that's the time it takes her to complete one length, 31.25 seconds. When she swims at a constant speed, so the minute you see constant speed, you're looking for Newton's first law, which is a law of balance forces. She exerts a force of 50 newtons. What is the magnitude of the backward force on her, and explain what causes it? So we're talking about law of balance forces. So if you have 50 forward, you also have 50 back. And so the answer is 50 newtons backwards. And what's causing it? Well, obviously there's friction between herself and the water. So you'd need to say between swimmer, or between Judy and the water. Last part of the question, if she now increases her forward force to 60 newtons and her backward force remains the same. So we're going to draw that in. It says, first of all, draw the two forces on the diagram and calculate her acceleration. So backward she has a force of 50 newtons, and forward she has a force of 60. Now her resultant force then is 60 take away 50 is her resultant force. So if we use F equals ma here, F forward is 60 minus 50. And that's equal to her mass, which we find up here is 60 kilograms multiplied by A. So 10 is equal to 60 multiplied by A. So A is going to be given by 10 divided by 60, 1/6. Or if you do that as a decimal, that works out as 0.167. I'm rounding that up to metres per second squared. Now be aware in that kind of question, you might be asked to calculate a resultant force and you're given an acceleration from a calculation in a previous question. And that previous question might be something to do with equations of motion. So just be aware of that you might have to use acceleration. But always, if you're not sure whether you're calculating acceleration using this law or using some of your equations of motion, which I'm going to show you in a minute, then always look and see, has it given something about or mentioned a force in the question, and has it mentioned mass? Now that part of the question, the mass is mentioned way up here. But if force and acceleration are in the same question, then it's most probable you're going to use F equals ma.